welcome to this talk about continuous feedback and OpenTelemetry. Now, before I start, I do have one confession, which is if you'd asked me about a year ago about these topics, I would probably not have known what you're talking about. I think in this sense, this talk is kind of a culmination of my own personal journey with observability and the role that it should play in the dev process. And I hope that by the end of this talk, I will have convinced you as well that observability is something that we should all be including not only in dashboards, but as an integral part of the work that we do in dev. So just a few words about me before we get started, and I'll get back later to the topic of how I actually came to be so infatuated with observability and continuous feedback in general. But I'm a developer. I've been an architect, a scrum master, a team lead, a product manager, and all sorts of technical roles that all highlighted these sets of problems that I'll be discussing today. My own personal approach has always been kind of trying to be as evidence-based and skeptical about dev processes as possible, which also may have been the reason why I kind of stumbled into this area. And lately I started working on a new project that is completely related to observability, which is Digma AI, and I'll give a glimpse of that later as well. So to start us off on the topic, I'd like to talk about the hypothetical story of a developer called Bill. And Bill is a developer like many others. All he wants to accomplish is to get his feature into production. But the journey he had to go through really changed over the years in order to do so. We sometimes call that the definition of done, or what needs to happen for the story to reach its completion. And feeling kind of like an old geezer, but when I started 20 years ago, it was all about the code, right? It was about getting done with the coding part, then we ship it off to the QA department across the hall, and sometimes it would ricochet back to us, sometimes not. Often it did. And then there would be a lot of fun, very philosophical arguments about what's a feature, what's a bug. And eventually they would just continue that kind of chain of events that would eventually get it tested, regression tested, and then included in the next release. But of course, releases became shorter, everything became more continuous, and the definition of done changed. So then it became obvious that it's not enough just to maybe include, complete the code, but you also want to include tests, think about the test plan, and do a lot of other things to make sure that you're done with the story. And deployment too, like once it was maybe only IT or DevOps would worry about that, but today it's more common for developers to also know how to use Helm files or Terraform and know how to deploy this new component or piece of functionality that they want to include in production. So Bill is doing all of that, and he has a great CI, and he has an awesome GitOps process, and he's actually the master of all of these different technologies. But the question is, what happens then? So what happens when the code goes to production? What should he do after he deploys the feature? So ask yourself, in your companies, what do you do after a feature gets deployed into production? And what I personally would want to do as Bill is kind of know, well, did it work? What happened with this code that I just pushed in? If I rolled in an optimization to a query, did it improve the performance or no? Did it alter any other system behaviors, maybe for related flows? Was it at all used? I've heard a lot of horror stories about developers who rolled out a crucial piece of code only to discover months later that it was kind of one if statement away from getting executed. So all of these questions are extremely important, but what we find out is that often what would happen instead is that once rolling in this feature into production, there would be much rejoicing and then taking on the next feature. And this has to do with kind of a gap that we have in the whole feedback loop, right? So when we code, there is no lack of feedback to get about how the code is working in our own dev environment. We have some limited feedback from tests, which is basically yes or no, failed or pass, which is okay, right? It is at least something. But when it comes to production, usually we kind of roll it into production, and it can become very difficult to then spend more effort and assert whether it worked or not, especially because sometimes these things are asynchronous. Like it would take weeks until somebody, or maybe until it reached full capacity in terms of users being aware of it and using this new feature. And as a product manager, I have to say that we also suffer from kind of a new feature bias, where a developer would tell me, yes, I just completed this feature and I would be awesome. What about the next one? And that would always be important, because this is what we measure ourselves by, right? We have a roadmap. We're trying to advance it. We committed to it. I've yet to see a roadmap that has this item or a big chunk of time allocated to, let's get feedback from what we just rolled into production. However, my personal impression as kind of somebody who's been on both sides of the fence is that essentially, if all we're doing is just accelerating releases, all we're doing is kind of throwing features over the fence at a higher velocity. So we're just going to this precipice of production, pushing the features over the cliff, and then rinse and repeating that, but not getting enough feedback maybe about how the code is actually faring in the real world, and to the extent that we can actually continually improve it. Now, when I thought about this topic some more, I found out that it actually should exist based on all of the models that we know. So this is, by the way, one example of a diagram that I found online, and I found numerous examples kind of exhibiting this same problem, where there is a piece missing here, right? You can see tools that are associated with every aspect of the DevOps process, from build to continuous integration, continuous deployment. But continuous feedback, for some reason, is left orphaned, with maybe Salesforce, for some reason, being associated with it in this diagram. But usually, we don't have any such tools. More than that, if I asked you, do you practice continuous integration? You'd probably say yes, because that's the common practice today. If I asked you, do you practice continuous deployment, then you would probably say yes as well. But who would answer yes to, do you practice continuous feedback? And where is your continuous feedback platform? Where is the platform that will not take code from your IDE to production, but take the data about that code from production and bring it back into the code? Or this feature design or the next feature design, it doesn't matter. With that in mind, I started thinking, well, if only we had access to objective data about the application that we're running, that would be a non-effort for Bill or for myself or for anybody else to reach and have as kind of a contrast to our work. We would completely be aware of everything that is happening with our code in production, both if we're measuring it or if we're evaluating code changes and so on. And this is a perfect segue to OpenTelemetry, because OpenTelemetry is the technology that makes it much easier to get access to that data. And in this sense, I want to talk for a second about why I think OTel is important. Now, I'm by no means the #1 expert on OTel. There are great people working on that. But more from an end user perspective, the #1 most significant thing about OpenTelemetry is that finally there is something that everybody seems to agree on. If it is the commercial APM, some of the cloud providers are moving there, and all of the platforms and libraries that we're all using now have one very kind of singular thing to support, and they know that a lot of people will benefit from any instrumentation they will add there. So that means that as a developer, as an end user, I can now count on the fact that most of the platforms that I will use will already have built-in support for that. So getting data out now has nothing to do with trusting some spec or client or some intrusive process. It's more like turning the lights on in the sense of, okay, I will add a few lines of code, I will enable OTel, and all of a sudden I have this wealth, if anything, I would argue too much data available to me about my application and how it behaves. To illustrate that, I've created a sample repo that demonstrates how to use OTel and get some value out of it, which is really the important part. So I was looking to create something that's different from your usual CRUD apps that tend to be very shallow. And as I was watching the movies at the time with my kids, I decided to create an API for the Gringotts vaults of the hairy wizarding worlds, because why not? Now, one thing, and I won't go into all of the boilerplate setup that has to do with setting up OTel, because A, it's simple, and B, there are lots of different tutorials and quick guides on that. I do want to talk about two things. The first is the collector concept, and OTel does have this very neat concept of a collector, which is, for lack of better words, just a router that tells basically defines what types of traces, metrics, and other observability streams they are, how to incept them, and where to send them off. In this case, as you can see, this is my own pipeline. I have some exporter for Logs.io, Jaeger, Prometheus, and some other products, and you basically create a pipeline combining these different entities. And that's very simple YAML file, and it takes all of that logic out of the app, which is great. It also includes support for things like sampling and processing and other really neat things that start to matter when you're doing that at scale. The other thing I want to mention is just how easy it was to get so much data out of this app. So what you see here are just the out-of-the-box packages found in PyPy for this project I was using. And to look at it from a more schematic perspective, this is kind of the architecture of the Vault API that I created with Postgres and some RabbitMQ and some other components. And all of these kind of purple diamond shapes that you see here are just automatic instrumentations that I got out of the box without doing anything or changing any code. So right out the bat, I had a lot of data already to play with coming out of this application. Again, as a developer, something very useful, but how do I actually access that data? And there are several commercial solutions that allow you to do that, but I chose to kind of focus on the open source ones. And one of the kind of most common one is a tool called Jaeger that just lets you visualize the traces. So you can actually understand what your code was doing at a given point, maybe even do some comparisons. Let's take a look. So again, as a prerequisite, I did some boilerplate that I'm not going to get into about kind of just adding some boilerplate around OTel. But now I'm ready to kind of explore how I can actually visualize my code. So I have here an API. This is a fast API application, by the way. I have here the appraise post operation, really important appraising the vault. There will be some automatic tracing that will happen just because I've included some packages, as I mentioned, like the fast API instrumentation. And if I look at specific functions, you might notice that I have some manual instrumentation as well, which is basically my way of defining traces. So as I mentioned, one of the tools that help me make sense of all of that data is Jaeger, which is an awesome tool that I really like, and it's also free and open source and easy to start as a container. I have here some traces for that specific operation we were looking at before. The authorized vault owner for access, and I can see interesting things about it. I can see the duration, I can see any errors, and I can actually drill in to see exactly where the time gets spent. And what you'll notice here is that a lot of this information was automatically added. So all of these select statements, for example, were automatically populated just by virtue of adding the automatic instrumentation. So all in all, pretty cool. And suddenly I'm not at all in the dark about what my code is doing in production, where it's spending its time and so on. And there's even a neat feature for comparing different traces, let's say the slow one and the fast one, and understanding what's the difference in their execution, which is awesome. So you would think, there it is, problem solved. We have tons of data about the application. We can now use that for feedback. Bill can get back the information about how his code executed. Everything should be great. But we're not. Or at least most organizations are not using continuous feedback still. So what are we missing? Where is the missing ingredient that kind of prevents us from being awesome with the observability data? And over the past several months, I've been exploring that topic, and I've found that there are three main reasons in 99% of the organizations that I talk to about why we're not actually being productive with observability data. So the first reason is expertise. It's not by chance that you see here a picture of somebody doing house repairs, because for me, that's my one of my weak spots where I actually don't know how to do anything with house repairs. I'm completely clueless, which is why I try to avoid it. And in a similar way, if I'm a developer, I may not be that well versed in how to extract, I don't know, statistics or what percentiles are, or why you can't average them, and how do I actually get information out of this, so much raw data that there is out there, because it does require expertise. And what happens is sometimes you would have like two people in the organization, they're the performance guys, and the other ones would not actually know how to do all of those things because it takes effort. And even if you are an expert, it might require you to do things out of kind of that are not budgeted in your daily activities. The other aspect is context switching. So, there's enough context switching as it is. If I need to now stop what I'm doing and worry about how to get statistics out of traces, or start exploring things and trying to understand whether it's an anomaly or not, that takes time. Lastly, there is kind of a dashboard fatigue. There's so many tools and so many different dashboards and so many new things to learn that we're kind of in an information overload phase. So with these three reasons combined, it's kind of actually not that surprising that while we've very successfully provided the infrastructure to create so much useful data, like troves of amazing insights about the application, it's not accessible and we're not getting it as a part of the day-to-day dev. So this might be a good time to talk about me and why I'm so up in arms about it. And, Bill was my team members, and I was shocked and kind of refusing to accept the fact that there was so much information on the one hand that observability was collecting, and so little was reaching me as a developer and my team. And trying to connect these two dots was kind of what I've been thinking about very actively for a while. And from that perspective, I started kind of thinking about how can we create a platform that will allow us to actually make that accessible and solve all of these problems for you about expertise and not being reactive and looking around in dashboards, but instead kind of make it accessible where you work so that you can actually use all of those useful kind of data points when you code. And after thinking about it some more, I got to the conclusion that I was also thinking about it very linearly. So yes, I check in my code, it runs tests, I can then validate how it worked in production. But it's a loop. So all of that information was there all along. So hypothetically, there are other questions that we could ask that are new if we had that information in other phases of the development process. So before we even get started on writing any line of code, we can see, well, where are the bottleneck areas? What are the throughput that this needs to support? Where is kind of the piece of code where if we add anything, it will propagate through the entire system? And where are those places that are not that important or maybe don't matter as much in terms of performance, as an example. Or I can look at runtime errors and understand where they are. And I can look at who's using a specific piece of code. So there are all sorts of data points that are extremely relevant that I can introduce before I make code changes, as I'm planning them to make maybe better design that meets the requirements. Second is once I've kind of started, I can get a lot of tracing data from the CI to make sure, I didn't make any, obvious mistakes. And then lastly, even before I check this code in, I could look at that information in the code review. And then when it's already in production, this is where I can start measuring its effect. So I was thinking about the problem in a very narrow way, but then I understood we could use this information everywhere. And this is the big paradigm shift, I think, in development and in how we can actually use the data that observability is collecting for us. So here we're looking at the same information we saw before, the same code, only this time I'm going to kind of enable the continuous feedback aspect in my VS Code in this case. And immediately what you'll see happening is that I won't need to go looking around in dashboards and try to, again, utilize expertise I may not have to get to conclusions about how this code performs or works. I can actually see that right here in the code, and I'm noticing that this area is experiencing high usage. It's actually slowing down, which is interesting. And I can see additional information about this code that comes right from production. So in this case, I can see where are the bottlenecks, what happened to the duration, which seemed to be terrible, by the way, any runtime errors and hotspots that are kind of plaguing this area of the code. And I can go to that specific span we were looking at before, the authorized vault owner for access. Only this time, this information is kind of at my fingertips, kind of like IntelliSense or Find Usages. I can see who is using this, who am I affecting, and if we now drill into kind of look at the trace data on Jaeger, in Jaeger, it kind of comes from the example or from the code. So it's not fishing for trouble. It's kind of looking at a specific concrete example and seeing how it affects my work. So this, I think, kind of crystallizes the vision of how I think we can actually leverage observability in the future. So this was just an example of how continuous feedback can work to take all of that data that is seldom left unused. And I sometimes look at it like junk mail because there's so many traces and metrics that we're collecting that are just sitting there with nobody actually putting them to use. And how can we take them and kind of include them into the dev process in a more relevant way? But I think shifting to continuous feedback has to start with something much more fundamental. And I'm very happy to see that other developers are already doing that, which is shifting to the perspective that we own our code all the way to production and beyond. So we need and have to understand exactly how it behaves. We need to have the tools to get the information and the tools to analyze the information. Now, beyond that, we also need to implement a feedback-oriented dev process. And this is kind of wearing my product management hat again, where we have that bias towards new features and the whole organization is kind of striding forward towards the next feature and the next feature. So we need to include that in the basic ceremonies we practice so that we make sure that learning and feedback is not forgotten. Otherwise, we are, again, running blind. So being able to have a weekly feedback meeting in which we discuss what feedback we've received on this new feature we've rolled out and see if we're missing any probes to get more information. That's a must if we want that to actually happen. So continuous feedback is a really new concept, but we're really kind of looking forward to hearing what the community has to say about that. So we've created a Slack channel that is not about any one particular tool, but in general about practices, continuous feedback, useful tools and methodologies, and comparing thoughts and experiences. So very happy to see you there at continuousfeedback.org/Slack. we're a very new community, but you'll be very, very welcome, and we're very keen to hear your thoughts. That's it. Thank you for listening to this talk. Continuous feedback is only my favorite topic these days. I'm very happy to talk more. This is my email address, and Doppelware is my Twitter handle. And I'll also be on the Slack chat over at continuousfeedback.org. Thank you.